Good day, everyone, and welcome to where we are putting together solutions in the area of mathematics for students who are struggling. In this video, we'll be looking at Caribbean Secondary Examination Council or the CSEC Math papers, and we have similar channels for additional mathematics and primary math, which you can be found in the description down below. This video looks at the past paper questions for May 2024, paper 2. Don't forget to like the video and add any comments down below so we can help create other videos for those areas in which you are struggling with. If we look at the description down below, it has highlighted the playlist we suggest that you go through in the proper order in order to cover the entire CSEC Maths syllabus. Let's now look at the mathematics syllabus itself, and we can see that there are 10 major topics, where in paper 1 it is worth 60 marks, which are the multiple choice questions, with an overall weighting of 30%, while paper 2 is out of 100, which is what this video is about, and it's worth 50%. We also have a third paper, which is worth 20%, which brings us up to 100%. That third paper can be considered to be the SBA or school-based assessment, and that's an in-house project. Or it can be an alternative paper, and that would be for students who have no SBA, or who did the SBA and were not successful, or we used it more than once, or the SBA has been more than 2 years old. So if we look at the first question that comes in paper 2, it's worth 9 marks, and it's a combination of the first two topics, number theory and computation, as well as consumer arithmetic. And if we move on, there has been a change in the syllabus so that with the topic of sets, it is no longer assessed in this paper, paper 2, only in the multiple choice. In the next topic, measurement, it comes for one full question with 9 marks. And for statistics, it's also for one question with 9 marks. The topic of algebra will be covered where it is assessed for 10 marks in paper 2. And the topics of relations, functions, and graphs comes across 2 different questions for a total of 20 marks. It's similar for geometry and trigonometry with 21 marks across 2 questions. And we have our final question on the paper, vectors and matrices, with 12 marks, and an investigation question, which can be a combination of any of the other 9 topics. And that gives us our 100 marks in this paper. So now let's look at the actual paper itself, and let's see what's happening at number 1A. Part 1. Calculate the value of the square root of 7.1 squared plus 2.9 squared, giving your answer correct to, part A, 2 significant figures. So we can work this out. Let's rewrite what they're giving us. 7.1 squared plus 2.9 squared, the square root of that. And we can use our calculators. 7.1, if we square that, we're going to get 50.41. And if we square 2.9, you're going to give us 8.41. We can now do the summation, add the 2 numbers inside there, and we're going to get the square root of 58.82. And using our calculators, that will give us 7.669, etc. Now, let's look at the question again. It's asking us to give our answer correct to 2 significant figures. So let's recall what that means. The first significant figure will be the number with the most value. And if we look at 7 ones, 6 tenths, 6 hundredths, and 9 thousandths, the number with the most value will be the 7 for 7 ones. The number with the second most value will be 6 tenths. So let's underline that. And now if we're going to write it to 2 significant figures, it's trying to figure out whether the answer will be 7.6 or it will move up to 7.7. So how do we know? we look at the number which comes after that number is 6. So since it's 5 or more, it means that the number 7.66 is closer to 7.7 than it was to 7.6. Now let's go on to the next part. Give your answer correct to 2 decimal places. So we just worked it out, and we know the answer is 7.669, and we want it to 2 decimal places. So the first decimal place would mean where the place value is tenths, which is the first 6. And the second decimal place will be where the place value is hundredths, which is the second 6. So let's underline that. And if we're going to write this to 2 decimal places, either it will be 7.66 or it will go up to 7.67. And what indicates which one it is closer to will be the number that comes after the 9. So because of that 9, it means it's closer to 7.67. Notice we put an approximate sign there because we are approximating what it is, not an equal sign. Let's go on now to part 2. Write the following quantities in ascending order. So we have 12 over 25, 0.46, and 47%. So we have them as a fraction or common fraction. We have them as a decimal fraction. We have them as a percentage. So in order to compare them, there are different ways we can do it. One way is we can convert all to the same type of number. So we can convert all to decimals. So 12 over 25, we can use our calculators if we want. And that will give us 0.48. And 0.46 is already a decimal fraction. And 47% is 47 over 100, which is 0.47. So now that we have written the 3 different numbers in the same form as a decimal fraction, we can now adjust it and put it in ascending order. Let's recall ascending order means from smallest to largest. So the smallest will be 0.46, followed by 0.47, and that is less than 0.48. Now, of course, we want to write it how it was given in the first line. So 0.46 is what it was given as a decimal. 0.47 was given as a percentage, so let's write it like that. 0.46 is less than 47%, which is less than, what was 0.48? The common fraction, 12 over 25. Let's now go on to part B. Mahindra and Jaya shared $7,224 in the ratio 7 to 5. How much more money does Mahindra receive than Jaya? And how do you know that Mahindra received more money? Because he received 7 parts to Jaya's 5 parts. So if we consider Mahindra and Jaya and we put them together, that will give us our total. So Mahindra got 7 parts, Jaya got 5 parts, so in total we have 12 parts. Now if we go back to the first line and look at it, Mahindra and Jaya shared $7,224, which means the total, which is 12 parts, is equal to $7,224. And by the unitary method, we can find for 1. So for 1 part means we're dividing by 12 on the left-hand side, then we can divide by 12 on the right-hand side. So 1 part will be $7,224 divided by 12. And what do we want to find? We want to find how much more money does Mahindra receive than Jaya. Mahindra received 7 parts, Jaya received 5 parts, which means that Mahindra received 7 minus 5. That's the difference. So that is for 2 parts. So 2 parts will be 7,224 divided by 12 multiplied by 2. As such, the 2 parts is equal to $1,204. So that indicates that Mahindra received $1,204 more than Jaya. Let's move on to the next part, where in number 1C, the present population of Portsmouth, and we'll consider that the present population to be 100%, is 550,000. So it is expected that this population will increase by 42% by the year 2030. So it's going to get larger. So we know 100% is 550,000, that's present day, and it's going to increase by another 42%. Write the number 550,000 in standard form. So 550,000 is really 5.5 multiplied by 100,000. And if you want to double check that, look at the place value for the first number, the most significant number, 5. And that would be hundreds of thousands. So to write it in standard form, all we need to do is convert the 100,000 into a base form. So 5.5 multiplied 10 to the power 5. Part 2 now. Calculate the expected population of Portsmouth in 2030. So we know 100% of the people presently gives us 550,000, and we want to add another 42%. So there are a couple different ways you could do this. You can find out what is 42% or 550,000 and add it to the 550, or we can just find out for the total in 2030, which is 142%. So 142% or 142 over 100 multiplied by 550,000, and we can cancel off zeros, 0 below and 0 above. So we get 142 times 5,500, and that will give us that we expect that the population will be 781,000 by the year 2030. Let's now go on to part D. The graph below can be used to convert between United States dollars, US, and Eastern Caribbean dollars, EC. So we have our graph. Look at using the graph in part 1, convert 2 US to EC. So if we look at our graph, we can see that US is on the y-axis. And if we go to the point where it's 2 US and we draw an arrow across in green, where it intercepts the sloped line, we can come down, and that value will be between 520 and 540. So that's 530 Eastern Caribbean dollars. Now for part 2, convert 70 EC to US. So if we want to start with EC, we're starting on the x-axis and going up, and where it intercepts the line, we'll go across to the left to find the US. Now there's no 70 US on the horizontal axis, but we can start at 7. So if we go up at 7 EC, where it intercepts and we go across, we can see that 7 EC will give us $2.60 US. So if we want to find for 70 US, we can multiply by 10 on both sides. So multiply by 10 will give us 70 EC, will be $2.60, multiplied by 10, which works out to be 26 US. So that will be the conversion rate using the graph. Let's now go on to number 2, part A. Laura needs to put mesh around 2 seed beds to protect her seedlings. Altogether, she uses 60 meters of mesh. One of her seed beds is a rectangle, as we brought it up there, and the other is a square, as shown in the diagrams below. The width of the rectangle is x meters, so we have an x there, and the length of the rectangular seed bed is 3 times its width, so it will be 3x. And the length of a side of the square is y meters, so we have some unknowns that we're giving there to show the relationship. Part E, using the information given above, derive a simplified expression for y in terms of x. Now, one of the things we know, if we go back to the first line, is that altogether she uses 60 meters of mesh, as she's putting mesh around the 2 seed beds. So what that means is that the perimeter of the rectangle and the perimeter of the square would be 60 meters. So we know perimeter of a rectangle, we can add up the 4 sides, x plus 3x plus x plus 3x, and the perimeter of the square will be y plus y plus y plus y, and all that will be equal to 60 meters, because that is how much mesh she had. And we can simplify. 1x plus 3x is 4x, plus 1x is 5x, plus 3x is 8x. 8x plus 1, 2, 3, 4, 4y is equal to 60. And we can simplify it by dividing throughout by 4. So 4 into 8x is 2x, plus 4 into y is equal to 15. And let's go back to what part A is asking us. Using the information given above, derive a simplified expression for y in terms of x. So we would like y equal to something. So we have 2x on the left-hand side. We can minus 2x on both sides. So it'll give us y is equal to 15 minus 2x. And that's part A. Let's move on now to the next part, where the question is asking us, the area of the rectangular seed bed, which is on the left-hand side, is equal to the area of the square seed bed on the right side. So now we have more information. As such, part 1 uses information and your answer in part A, which we have as y is equal to 15 minus 2x, to write down a quadratic equation in terms of x, and show that it simplifies out to x squared minus 60x plus 225 is equal to 0. So we're required to prove something. Now we know the area of the rectangle is equal to the area of the square. And what's the area of a rectangle? Length times breadth. What's the area of a square? Length times breadth. So the area of the rectangle, length times breadth, will be 3x times x. And the area of the square is length times breadth, y times y. And we can substitute after we simplify. So we get 3x by x is 3x squared is equal to y squared. And by substituting for y from part A, we get 3x squared is equal to 15 minus 2x all squared. And you can go and work this out by drawing the diagrams and expanding 15 minus 2x times 15 minus 2x, or you can use the method of FOIL or any other method. There are so many different ways. So 3x squared is going to work out to be 225 minus 60x plus 4x squared. And we can move everything across because we want to prove that it's equal to 0. So 0 is equal to 225 minus 60x plus 4x squared minus 3x squared. And we can rearrange. So 0 is equal to x squared minus 60x plus 225. And we can draw a small square or write QED to show that we have done the proof. Now let's move on. We've already done those parts here dealing with perimeter and area. Part 2 now. Solve the equation, the same equation we just got, 0 is equal to x squared minus 60x plus 225, using the quadratic formula. So if we write it back and we consider what are the coefficients, the coefficient of x squared is 1, we have that in red. The coefficient of x is minus 60, we have that in green. And c is plus 225. So that'll be a, b, and c when we write our formula. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Remember, this formula is given in the formula sheet. And we can simply substitute because we know b is minus 60. So we can write x is equal to minus 60 plus or minus the square root of b squared, which is minus 60 squared, minus 4 times a, which is 1, times c, which is 225. So that works out to be minus 60 minus minus 60 works out to be 60 plus or minus the square root of 3600 minus 900, which is 2700, all over 2. And we can approximate that to be x equal to 60 plus 52 over 2. So that will give us 56. Or we can say x equal to 60 minus 52 over 2. 60 minus 52 is 8. 2 into 8 is 4. So x is equal to 4. So by solving by the quadratic formula, this formula works out when x is equal to approximately 56 or 4. And now, let's calculate the total area of the two seed beds. Now, we know y is equal to 15 minus 2x. And if we consider we have two different values of x, we're going to end up with two different values of y. So let's try when x is equal to 56. So y is equal to 15 minus 2 by 56. 2 times 56 is 112. So 15 minus 112 will give us something which is negative. Can the length of the square be negative? It cannot. As such, the answer x is equal to 56 does not hold for this particular situation. So we have another value for x. Let's try that. Y is equal to 15 minus 2x. And we're using that x is equal to 4 as a substitution. So 15 minus 2 by 4. 2 4s are 8, so 15 minus 8. So y is equal to 7. As such, when x is equal to 4, y is equal to 7, and those are plausible values. Now we need to calculate the total area of the two seed beds. The total area is equal to the area of the square plus the area of the rectangle. And if we recall, earlier information told us that the area of the square and the area of the rectangle were the same. So if they are the same, then we can write the total area will be the 2 times the area of the square, which will be 2 times length times breadth. 7 times 7, 7 sevens are 49, 49 by 2 is 98. So the total area is 98 meters squared. Let's now go on. Number 3, a vertical flagpole FP stands on horizontal ground and is held by 2 ropes. So we have the vertical flagpole. I have it in blue so you can easily identify it. PG and PR are 2 ropes, as shown in the diagram below. PG is equal to 18 meters, that's on the left-hand side. FR is equal to 9.7 meters, and angle FGP is equal to 38 degrees. So all that information is given. Part 1, calculate the height of the flagpole, FP. So if you want to get that height, which we have in blue, then let's recall our trig formulas. Generally, we have these formulas. First being dealing as a right angle triangle without any angles, and those relationships will be the opposite squared plus adjacent squared is equal to hypotenuse squared, better known as Pythagoras' theorem. Or in the second line, we have the trigonometric ratios, SOHCAHTOA. Sine theta is opposite of hypotenuse, cosine theta is equal to adjacent of hypotenuse, tan theta is equal to opposite of adjacent. And finally, we have the sine rule and cosine rules, which works for any triangles. So if we want to calculate the height of the flagpole, FP, let's picture it here, and let's extract it out, and let's put in the information. So FP, 18 meters and 38 degrees. And we would like to find FP. So since we have 38 degrees as a right angle triangle, FP will be the opposite angle, the opposite side. And we know the longest side, which is H, the hypotenuse. So if we look at our formulas, which one dealing with a right angle triangle deals with opposite and hypotenuse? That will be sine theta. So since we have that information, O and H and an angle, sine theta is equal to opposite over hypotenuse, and we can simply substitute because we know the angle. Sine 38 is opposite, which we have to find out, which is FP, over the hypotenuse 18. So if we consider that we cover off the 18, then what do we have? Sine 38 is equal to the opposite. And 18 was divided on the right-hand side. So how do we move it? By carrying it across or multiplying by 18 on both sides. It's still going to give us one where 18 times sine 38 is equal to the opposite, or FP. And using our calculator, we get 11.1 meters is the height of the flagpole. Now that we know that, look at part 2. Find PR, the length of one of the pieces of rope used to hold the flagpole. So let's pull it out and let's put in what we know. We want to find out PR, so we put a question mark there. And that's our longest side, so consider that to be H. We know the adjacent, FP. We just worked that out in the first part to be 11.1. And the base is given as 9.7. That's FR. So which formula are we going to use? It's a formula dealing with a right angle triangle, so it'll be one of either the first line or second line. And this question has no angles in it. So it'll be the first line. It'll be a question that has 3 sides only: opposite, adjacent, and hypotenuse. So this is where we're going to use Pythagoras' theorem. So opposite squared plus adjacent squared is equal to hypotenuse squared. And we can simply substitute 9.7 squared plus 11.1 squared is equal to 8 squared. So 94.09 using our calculators plus 123.21 is equal to 8 squared. So that works out to be 217.3 is equal to 8 squared. So H is the square root of that, of 217.3. So H, which is PR, which is the length of that rope, is 14.74 meters. And of course, it had to be less than the hypotenuse, which was 18. Let's go on to 3b. In the diagram below, PQ is parallel to MN. LRT is an isosceles triangle, and LT is a straight line. Find the value of x. So if we look at this here, we can see 28 degrees below on the right hand side at R, and it's the same 28 degrees at L. So knowing that, applying that rule, and this rule only works because PQ is parallel to MN, then we can extract this out, and we saw the 28 degrees, we have to find x, and we would need to know this entire angle here, because this entire angle will be vertically opposite. So x would be, which is in green, is the same as what is in purple, and we know part of the purple angle, which is 28 degrees. So our job is to go and work out the other part. So if it's an isosceles triangle, L, R, and T, and we know 28 degrees at R, let's consider that these two sides, LT and TR, are the same, because isosceles triangles mean two sides are the same. So if there's 28 degrees at R, then it means there's 28 degrees at L. So we can now put in 28 here as well on the purple side, which means that x is equal to 28 plus 28, because they're vertically opposite. Those angles are the same. So x is equal to 56 degrees. And the question has been solved. However, there's an issue with the question, and it is that we're not sure which two sides are the same in the isosceles triangle. So let's look at it a little differently. We know L, R, and T. We know the 28 degrees there. And just now we assumed LT and RT are the same. But it could be LT and LR are the same. And if that's the case, the angle which is 28 degrees at the base on the right-hand side at R will be the same at T. Therefore, L would be different, because if we add up the three angles in the triangle, it will add up to 180 degrees. So L plus 28 is equal to 180. 28 plus 28 is 56. So L is equal to 180 minus 56, which works out to be 124 degrees. As such, if we put in 124 degrees here, and then we look at our solution, what did we know? That x is equal to, which in green is equal to what is in purple. So x is equal to 28 plus 124. So x works out to be 152 degrees. So it's according to which two sides of the triangle are the same will cause the angle x to vary. It was 56 degrees in the first case, where LT and RT were the same. It's 152 degrees in the case where LT and LR are the same. But what about the third possible combination? Right? This question had this information lacking and caused three possible answers. So we know the basic triangle LRT, where it's 28 degrees there. But what about if it was that RT and RL were the same? If both of them were the same, then remember that all three angles add up to 180 degrees in a triangle, and L and T would be the same. So let's consider that L plus L, which is 2L, plus 28 is equal to 180 degrees. And to solve, we can remove the 28 on both sides. So if we minus 28 on the left-hand side, we'll be left with 2L, and we minus 28 on the right-hand side, 180 minus 28. So 2L is equal to 152. As such, L would be divided by 152, which is 76 degrees. So let's put that in. As such, when we put up our normal sketch here of where the angle is, x degrees in green across from it is 28 and 76. As such, x works out to be 28 plus 76. So x is equal to 104 degrees. So the angle x varied according to which pair of sides of the isosceles triangle were the same. Number 3C. The diagram below shows a shape T and its image Q after a transformation. Describe fully the single transformation that maps shape T onto shape Q. So if we look at T, we can see that its transformation or its movement onto shape Q could be one of the following. It could be a reflection, a rotation, translation, an enlargement, a glide, or a shear. So if we consider the idea that we can bring up that red dotted line which shows that it fits directly in the middle between both of them, so that we can fold one onto the other, then we can consider that to be a mirror line. So we can see that this has a reflection about the line y is equal to x. And just to recall, if we look at any points on that line, the x value and the y values are the same. 0, 0, 1, 1, 2, 2. So we can say y is equal to x. So the way to describe this will be a reflection about the line y is equal to x. The next part, on the diagram, draw the image of shape T after it undergoes a translation by the vector -1, 6. Label this image M. So, if we consider what it means to translate, that means to slide it. So if we consider shape T and we're sliding it along the column vector -1, 6, it means we're moving -1 or 1 unit to the left. And we'll indicate that with a green arrow. And then 6 units upwards. So we'll move from 1 up to 7. 1 plus 6 is equal to 7. So if we consider, let's bring up the shape T as a blue trapezium, and we slide it 1 to the left and 6 up, it will come up to that point there, and of course we can label it M. Let's go on. So number 4, E. A rectangle PQRS has a diagonal PR, where P is a point -310 and R is a point 4 -4. So ideally, we can make a sketch, and when we're making our sketch of where these points are, just a freehand sketch, we want to put in oxy, O for the origin, X for the x-axis, and Y for the y. And we want to put in our points here, just an average of where they are, so it'll give us an idea of what's happening. So P is -310, so it fits into the second quadrant. And if we consider -3, that will be the x value, and 10 will be the y value. So somewhere along that position within the second quadrant is where P lies. R is 4 -4, so that fits into the fourth quadrant, where we consider that the x value is 4 and the y value is -4. So we have a general idea of this diagonal. Remember, it's a rectangle PQRS, and its diagonal PR is what we're being given the information about. Calculate the length of the line PR. So if we consider the line PR, then we can think of it as being the diagonal across that rectangle, and we could picture it as being from a right angle triangle's perspective, where we can move from P to the right. And how much are we moving? P is at -3, and if we go straight across to be in line with R, we're moving from -3 to 4. So -3 to 4 is a total of 7 to the right, so that's +7. And then we're coming down. We're starting at 10, and we're coming straight down to the position of R, which is at -4. So we're moving 10 and 4, which is 14. But we're moving that 14 downwards. So we'll label that as -14. So let's recap. If we know that we have the main diagonal is what we're trying to find, its length, and we know the two sides, then we can use Pythagoras' theorem. Pythagoras' theorem says that the change in x squared plus the change in y squared is equal to h squared. And we know them. We just worked them out there. 7 squared plus -14 squared. 7 squared is 49 plus 14 squared is 196. and that will give us 245. So h, which is the hypotenuse or the length of PR, will be the square root of 245, which works out to be 15.7 units. Now that we've gotten that first part, let's go on to part 2. Determine the equation of the line PR. So now that we're looking at that line, we can see that there's a slope and it's moving downwards to the right. So let's bring that up with a green arrow so you can see what the equation of the line generally looks like. It's just a sketch. So how do we find the gradient? The gradient is change in y over change in x. And we worked that out already. We have it in purple. So that's minus 14 over 7, which works out to be 7 into 14, 2. So the gradient of PR is minus 2. And it makes sense because it's sloping downwards to the right, which means the gradient is negative. So let's recall that if we want to find the equation of a line, there are so many different ways to do it. Let's just pick one. Let's remember that the gradient is change in y over change in x. So the gradient is minus 2 is equal to y minus, and we can pick one of the points that lies on that line PR. So let's use the value r. You can try it yourself using p. So we're substituting there because the y value at r is minus 4. So it's y minus minus 4 over the change in x, which is x minus 4. And now we can carry across the denominator because it's dividing. And we're left with minus 2 times x minus 4 is equal to y minus minus 4, which will be y plus 4. So we can now expand the left-hand side. So minus 2 times x is minus 2x plus 8 is equal to y plus 4. And we can subtract minus 4 from both sides. That way we'll have minus 2x plus 8 minus 4 is equal to y. And we can solve stating that y is equal to minus 2x plus 4. And that will be the equation of the line PR. And from our sketch, it gives us a general idea that 1, the gradient is negative, and this equation that we found says the same thing at minus 2, and that it's cutting the y-axis at a positive value greater than 0. And we have that cutting at 4. Let's now go on. Number 4b. Two functions f and g are defined as follows. F of x is equal to 3x plus 1 and g of x is equal to x squared. So we would like to bring it up in a different format from what we're accustomed to, so we can use it like it's a flowchart. So if we consider our input for f of x to be x, and what does 3x means? Whatever our input is, we're going to multiply by 3. And then we're going to do what next? Add 1. So any number we have as our input, we multiply by 3 and we add 1, and that will give us our output. And our output is f of x. So that's a different way of representing the same information. And similarly, we can do that for g of x. So if the input is x, any number, and what do we do with that number when it comes in? We square it. So that's x squared, and that answer will be our output, g of x. So there's different ways of representing it for students to get a better grasp of understanding relations and functions. So part 1, find in its simplest form an expression for f of x minus 2. So if we consider that, that will be the peach colored squares up on top, that flowchart. As we call f of x is 3x plus 1. And our input is no longer x, but x minus 2. So if we're following from the flowchart, it means that if we have f of x minus 2, we're going to say 3 times that. 3 times x minus 2. And then we're adding 1. And now we simply just use some algebra by expanding, right, the brackets. So 3 times x is 3x, 3 times minus 2 is minus 6 plus 1. And we can simplify, so f of x minus 2 is 3x minus 5. Let's now go on to the next part, part B. Find g of 3x plus 2 plus 10. So we know what g of x is, so we can bring that up. G of x is equal to x squared, and it's indicated in the yellow rectangles there. And instead of our input being x, our input is now 3x plus 2. So 3x plus 2 would be 3x plus 2 squared. And there are different ways to work this out. So I'll do a physical representation so you can see it. If we consider we have a square whose length is 3x plus 2 and whose width will be the same because it's a square, 3x plus 2, then we can consider 3x times 3x to be a square and 3x plus 2 to be a rectangle, 2 times 3x to be another rectangle, and 2 times 2 to be the purple square. So if we're going to do that and find the areas of each one, then 3x times 3x is 9x squared, 3x times 2 is plus 6x, 3x plus 2 is plus 6x, and plus 2 times plus 2 is plus 4. Therefore, 3x plus 2 squared can be written as 9x squared plus 6 plus 6, 12x plus 4. And what do we actually want? We want g of 3x plus 2 plus 10. So 9x squared plus 12x plus 4 plus 10. And that gives us 9x squared plus 12x plus 14. Mr. Morgan administered a spelling test to his class. The table below shows the number of words out of 10 that each student spelled correctly. So if we look at the table, we can see that there were 8 students who spelled 5 words correctly, 4 students who spelled 6 words correctly, and so forth. For the data set shown above, state the Part A mode. So let's recall what mode is. Mode, M-O-D-E, is really asking us to figure out which number of words appears the most. So we look at which one of those are most frequent, and we can tell that out of the frequency, 8 was the highest, which indicates to us that there were 8 students who were able to spell 5 words correctly. And that is more than any of the others. As such, the mode is 5. The mode is not the amount of times it appears, but which one appears the most. Part B, the median. And of course, when we're thinking about median, we're thinking about taking the data and putting it in order, ascending or descending order, and then finding the middle term. So if we look at our table, what do we recognize? We have 8 students who got 5 words right and 4 who got 6 words right. So that's 8 and 4, 12. And if we add up the number of students, 12 and 2, 14, and 2, 16, and 3, 19, and 4, 23. As such, the total frequency, we can write that as sigma f, sigma indicates total, is 23. So if we put these 23 numbers in order, what is the middle term? So the middle of 23 consecutive terms will be the 12th term. And if we look at the students who got 5 words right, there were 8 of them. So if we had to write it, we'd write 5 by 5 by 5 8 times, followed by how many students got 6 words right? 4 of them. So we'll have 6 and 6 and 6 and 6, and 2 sevens, and then 2 eights, and so on and so forth. So if we're looking for the median, the middle term, which is the 12th term, let's recall that if we're thinking about the median or the middle of an odd amount of numbers, it will be an exact value. So if we had 5 numbers, the middle of that will be 3. As we have 23 numbers, the middle of that will be the 12th term. And that is the last 6. So the median is 6. Calculate the mean number of words spelled correctly. So if we would like to find the mean, which specifically means the arithmetic mean, then what we're trying to find is normally what we consider the average. And how do we get the average? We actually add up all the terms and divide it by the number of terms there are. So, if we look at the first case, which we have in purple, how would we get the total amount of words that these students got right? Well, we have 8 students getting 5 words right. So ideally, it will be 5 plus 5 plus 5 8 times. And that will give us a total of 40. And repeated addition, adding 5 so many times, it's really the same as multiplication. So we can say 5 times 8 is 40. And if we look at the first column on the left side, 5 can be indicated by the letter X and 8 by the letter F. So when we multiply them, it will be F times X. Similarly, for the next 4 terms, as we have written out in part B in median, one student got 6 words right, and another got 6, and another got 6. 4 of them got 6. So 6 fours are 24. And for the next case, we have 2 students who got 7 words right, so that'll give us 14. 2 students who got 8 words right, which will give us 16. 3 students 27 right. And we're basically counting how many words they got correct. And for the last one, we have 4 students. Each student got 10 words right. So in all, that will give us 40 words. So how many words were spelled correctly in total? It would be 40 words plus 24 plus 14. So that's 64 plus 14 is 78. 78 plus 16, 94, and 27 and 40. So that total is 161. And if we divide it now in order to find the average, remember average or arithmetic mean is represented by x bar. That is equal to the total of f of x, sigma fx over sigma f. So it'll be 161 divided by 23, which will serve to be exactly 7. So the mode was 5, the median was 6, and the mean was 7. Let's now move on. So we go on now to number 5, part B. The attendance officer at a particular school recorded the time T in minutes taken by each student in a group to travel to school. The data collected is shown on the cumulative frequency curve. So we can see that the curve, the OGIV or cumulative frequency curve, has the normal traditional shape. Using the cumulative frequency curve, find an estimate of part 1, the number of students who took at most 32 minutes to travel to school. So if we look at our axes, where can we find 32 minutes? Minutes is on the x-axis or the horizontal axis. So what can we do? We can draw an arrow up from 32, and where it intersects with the curve, we can now go to the left and recognize that. So we found that 52 students at most took that length of time to travel to school. And let's go on with part 2. What we want to find is an estimate of the interquartile range. So the interquartile range would be Q3 minus Q1. And if we have an idea, Q1 will be approximately, because it's an estimate, the same point that we came out in part 1, which works out to be 32. And Q3 would be 3/4 of the way. We have 220 in all, so 3/4 of that will be 55 times 3, 165. So we have it indicated there. And if we would like to find how many minutes it is, we can draw a line across from Q3, 165 coming across, where it intersects, comes down and gives us a value. The difference, 54 minus 32, Q3 minus Q1, the interquartile range. And those values are both in minutes, so 54 minutes minus 32 minutes, that difference is 22 minutes. So that will be our interquartile range. Let's now move on. As we come to number 5, part C, the letters in the word positivity are each written on separate cards and placed in a bag. So we have all 10 letters there. Dacia picks 2 of these cards at random with replacement, meaning that if she picked the letter P and took it out, then we will replace it by another P. Find the probability that she picks the letter I and then the letter V. So you'd like to find the probability of that occurrence happening. So with these 2 different events. So the probability of picking an I, if we look at it 1 eye, 2 eyes, 3 eyes, so there are 3 possibilities of her picking the letter I out of 10. So the probability of picking the letter I is 3 out of 10. And then she picked the letter V. So what's the probability of picking the letter V? Well, we have 1V, you can see it changed up above, out of 10. Remember, because it's a replacement, even if we took out an I, we'll be replacing it with another I. So it'll still be out of 10. If we took out the V, we'll replace it with another V. Now that we know the individual probabilities of selecting the I and the V's, what is the probability that she picks I then the letter V? So the probability of I and then the probability of V, it's the same as multiplication, probability of I times probability of V, which is 3/10 times 1/10, which works out to be 3/100. So the probability of her picking these 2 in order will be 3 out of 100. Let's now go on now as we move on to part 6, where it says in this question, take pi to be 22/7. The diagram below shows a gold bar in the shape of a trapezoidal prism. Let's recall that a prism means that the cross-sectional area, which in this case is a trapezium or trapezoid, remains constant throughout. It remains uniform. So that shaded area remains the same from the front, closest to us, to the back. Its volume is 2,886 centimeter cube. So we know the entire volume of the prism. The length and height of the prisms are indicated on the diagram, 31.2 centimeters and 8.72 centimeters. Calculate the area of the shaded cross-section. So if we look at our formula sheet, the first equation given there is the volume of a prism. And the volume of a prism, whether it's trapezoidal or not, is area times height. Area being the area of cross-section or the shaded area, which is what we want to find. And height would be how far that area went back. So we can substitute 2,886 is equal to area times 31.2 because that is how far the area at the front to the back is. And of course, we can now solve by dividing. 31.2 is multiplying on one side, we'll move it across, we'll divide. So the area is 92.5 centimeters squared because our answers are in cm. Now we move on to the second part. We want to find the cuboid shaped gold bar shown below has the same volume as the trapezoidal prism gold bar displayed at A. So both of these diagrams have the same volume. Calculate the height of the cuboid gold bar. So the volume of the prism is equal to the volume of the cuboid. And we know the volume of the prism is 2,886. And the volume of the cuboid would be length times breadth times height. And if we look at it, we know 2 of those. So the only thing that's missing in this line is h. So if we substitute, we should be able, there's only one unknown, so we should be able to solve for that. So we could work it out, 2886 is equal to 250.92 times h. So we could carry it across, it'll divide. So our height works out to be 11.5 centimeters for the cuboid. And that way, when it's 11.5 centimeters, the volume of the cuboid is the same as the volume of the prism. Let's now move on to the other part, 6b. The trapezoidal gold bar is melted down and all the gold is used to make 6 identical spheres. Calculate for each sphere of gold its radius. And the volume of a sphere is given 4 to the pi r cube. So if we consider that the volume, let's write the formula, is equal to 4 to the pi r cube, what is the volume of a sphere? The volume of the entire thing was 2,886 centimeter cube, and that was for 6 spheres. We want to find for one sphere, so we have to divide by 6. So it'll be 2,886 divided by 6 is equal to 4/3 times pi, which they gave us above as 22/7 times r cubed. And if you look at the line now, we have one equation and we have one unknown. So we can solve. So let's just move it across. First of all, 2886 is 481. 4 times 22 is 88 over 21 times r cubed. The 88 is multiplying on the right hand side. When I carry it across, it'll divide. And 21 is doing this dividing. When I carry it across, it'll multiply. And now that works out to be 114.78 is equal to r cubed. So what is r? The cube root of that, 4.86 centimeters. So when the radius of the sphere is 4.86 centimeters, it gives us a volume where all 6 spheres in total will be equal to 2,886 centimeter cube. Let's go on to the next part. Part 2. Calculate for each sphere of gold its surface area. And we have a formula given for that. So let's write the formula. A is equal to 4 pi r squared, and we would like to find A, the surface area. We know 4, we know pi, and r we worked out in part 1. So we can simply substitute 4 times pi, 22 over 7 times 4.86 squared, and using our calculators, we get our answer. Area is equal to 296.93 cm squared. Notice that when we worked out the radius, it was the 2 decimal places, so we're working out the area to the same amount. Can't be more accurate. Moving on now to the next part. We want to calculate for each sphere of gold its mass to the nearest kilogram, given that the density of gold is 19.3 grams per centimeter cube. And let's recall density is mass over volume. So if we writing the formula density is mass over volume, and it's given as 19.3 grams per centimeter cube, let's recall that our answer wants it to kilograms. So how do we change grams to kilograms? We divide by 1,000. So 19.3 divided by 1,000 is the density. We don't know the mass, we have to work that out. But we know the volume. From part 1, on the third line, we saw 2,886 divided by 6 is 481. So we know the volume in centimeter cube. So when we have this, we can now find the mass by just carrying 481 across and multiplying. And our answer will be 9.28 kilograms. And that will be the mass of one sphere of gold. Let's now go on. As we move on to number 7, the diagram below shows the first 4 diagrams in a sequence of regular hexagons. So this is diagram 1, and diagram 1 to 4 was shown, but I'm going to bring them up individually and show the link between diagram 1 and 2, these successive diagrams. So that is diagram 1, which has 3 hexagons. Diagram 2, it's actually the same thing with an addition of 2 more. So I'm trying to show that they are similar, and let's change the color so we can see what was the addition. The addition was 2 more hexagons. So the entire diagram, diagram 2, all 1, 2, 3, 4, 5 hexagons makes up diagram 2, one same color. But I'm showing the difference here so students can see the link from one to the other. For diagram 3, we can start with what diagram 2 is, 5 hexagons, and add 2 more. And let me change the color so you can see what is happening. So there's 3 and 4, 7 hexagons. And what will happen in diagram 4? Bring up these 3 and 4, 7 hexagons and add 2 more. So if we add 2 more and highlight it, you can see the change from diagram 1 to 2 was adding 2 hexagons and adding 2 hexagons to diagram 3 and adding 2 hexagons to diagram 4. So hopefully you can pick up the pattern. Each regular hexagon is made using sticks of unit length. Complete the diagram below to represent the diagram in the sequence of regular hexagons. So if we look at this diagram here, we're trying to come up with diagram 5. So diagram 5, just as we saw with all the others, should be diagram 4 with an addition. So diagram 4 had 4 plus 5, 9 hexagons. We already have the 5 hexagons at a slope there. We don't have the 4 coming down above. So we can bring in 1 there, right? And it gets closer to diagram 4. And we need to bring in 1 more. So now we have a repetition of diagram 4. And how do you go to diagram 5? We need to add 2 more hexagons. And that will give us our complete diagram. So if we look at the patterns and look at slopes coming down, in diagram 1 we had 1 and 2. In diagram we had 2 and 3. If we look at a diagonal slope, in diagram 3 we had 3 and 4. Diagram 4, 4 and 5. And as such in diagram 5, 5 and 6. Let's now go on to the next part, where they're telling us that in 7 part B, the number of regular hexagons H, the number of sticks S, and the parameter of each figure P follow a pattern. The values for H, number of hexagons, S, number of sticks, and P, parameter, for the first 4 diagrams are shown in the table below. Study the pattern of numbers in each row of the table and answer the questions that follow. So if we look at it, in the first diagram, there were 3 hexagons, 1 plus 2. And if we counted it up, we would have gotten 15 sticks. And the total perimeter, which is the distance around the outside, was 12. For the second diagram, it was 5 hexagons, 23 sticks, 16 as the perimeter. And we continue with 3 and 4. So for diagram 5, we can actually read it off from what we had, or we can look for patterns. So let's see. I've found that it's better if students get the general gist of what's happening here. So let's look at that column H. In that column H, we had 3, 5, 7, 9. So if we're going backwards, then what that means is we are minusing 2. 9 take away 2 is 7, 7 take away 2 is 5, 5 take away 2 is 3. Therefore, 3 take away 2, right, would give us the top. So we're going to complete the rows, and that will give us 1. So how do we show that pattern is developing? Well, how do we get 3? We got 1 and 1 set of 2. And how do we get 5? We had 1 plus 2 sets of 2s, which is 4. 1 and 4 is 5. How do you get 7? 1 plus 6. So that will be 1 plus 3 sets of 2. How do you get 9? 1 plus 8. So that will be 1 plus 4 sets of 2s. So if we look at what's happening with the first column and the second column, 1 remains constant in the second column, and what is changing is 1, 2, 3, 4. And those are the values of D from the first column. If we're following that pattern, then what happens with the row with diagram number 5? It'll be 1 plus 5 times 2. And 5 2s are 10, and 1 is 11. So we're able to solve for that. Remember, we're solving wherever the dotted lines are that's missing. So we have 2 in this row, 2 in the next row, and 3 in the last row. And if we know that, can we get a general formula for this number of hexagons? It'll be 1 plus n times 2. N mean the number which is coming from the first column. So now that we have that general formula, 1 plus n times 2, what can we solve for now? For 47. It'll give us an idea for us that 1 plus what number, n times 2 is 47. So 1 plus 46 is 47. And how do we get 46? 1 plus 23 times 2. Therefore, for the first column, the diagram number, which gives us 47 hexagons, would be 23. Let's now move on to the next column. The number of sticks increased from 15 to 23 to 31 to 39, meaning that they're increasing by 8 all the time. So if we go backwards, we'll be subtracting by 8. 39 minus 8, 31. 31 minus 8, 23. 23 minus 8, 15. 15 minus 8, 7. So how do we develop the others? We can see for the first diagram, it'll be 7 plus 1 set of 8. And then 7 plus 2 sets of 8. 7 and 16 is 23. 7 plus 3 sets of 8. 7 and 24 is 31. And we're seeing a pattern developing in the fourth one, 7 plus 4 sets of 8. So by the fifth one, it'll be 7 plus 5 sets of 8. 5 eights are 40, and 7 is 47. We can check 191. It should fit the pattern. It will be 7 plus 23 sets of 8. And if we do 23 sets of 8, that will give us 160 plus 24, 184 plus 7, 191. And it works. So for the general rule of n, for any number, it will be 7 plus n times 8. And we're going to do a similar thing for the parameter. We know parameter is increasing from 12 to 16 to 20, 24, so it keeps increasing by 4. That means if we're working backwards, or we're going upwards, we're subtracting 4. 28 take away 4, 24, 24 take away 4, 20, 20 take away 4, 16, 16 take away 4, 12, 12 take away 4, 8. So for diagram number 1, it'll be 8 plus 1 set of 4. And then for the second diagram, 8 plus 8, which is 8 plus 2 plus 4, 8 plus 3 plus 4 by 4, 8 plus 4 sets of 4s. And of course, if we're looking at 5, 8 plus 5 sets of 4s. 5. So it works. And for the 823 diagram, then it will be 8 plus 23 sets of 4s. 23 sets of 4s is 92. 90 plus 8 is 100. And for the general rule, to complete the question, it will be 8 plus n times 4. Skylar says she can make one of these figures with a parameter exactly 1005. Explain why she's incorrect. So if we're looking at the parameter, we can use our general formula that we've found at the end, 8 plus n times 4. So 4n plus 8 is equal to 1005 because she says the parameter works out to be exactly 1005. So we can solve for n. We can remove the 8 on the left-hand side and on the right-hand side. So 4n is equal to 1005 minus 8. So 4n is equal to 997. As such, n is equal to 249.25 or 249 remainder 1. What does that mean? It means that if we consider what n is, and we say n is 249, meaning the 249th diagram, at that point in time, that will require how many, if we put it into it, 1004. And to go from 1 to the next diagram, which is the 250th diagram, we need 4 more sticks. So it'll be 1008. Therefore, if we look at what Skylar says, she says she can make one of these figures with exactly a parameter of 1005. The 249th diagram has 1004 as a parameter, and 250th diagram has 1008. So there's no diagram in between both of those. As such, with respect to her, she can't make that exact figure. That's why she's incorrect. Number 8a, the functions f and g are defined as follows. F of x is equal to 2x minus 1 all over 3, and g of x is equal to 5 minus x squared. And of course, we can bring this up looking as a flow diagram, something different from what you're accustomed to. So if we consider the function f of x, let's say that the input, whatever number that we're starting with, is x. And the first thing to do is multiply by how much? By 2. So that will give us 2x. And then what do we do next? The next step after 2x, we minus 1. So any number we have, if it's minus 6 multiplied by 2, get an answer, then minus 1 from it. And when we got that answer, which is our whole numerator, we now do what? We divide by 3. And that will give us our final answer or output. And similarly, we can do the same for g of x. Let's bring it up in yellow. So let's consider the input as x. And what do we start with? We say we have 5, the number 5 minus whatever we have as x, we square it. So 5 minus x squared, and that will give us our output, g of x. So part 1, determine the value of g of 2. So if we consider in our yellow rectangles there that our input is 2, can we work it out there? 5 minus, what is x? 2. So 5 minus 2 squared is 4. So 5 minus 4 should be 1. And we can do it like this as well. What students are accustomed to. G of 2 is 5 minus 2 squared. We wrote our formula, and then we're going to substitute. And now we're going to solve. 5 minus 4. So G of 2 is equal to 1. That's part A. And let's go on to part B. Find the value of f inverse 3. Now we can first of all take f of x and go and find the inverse function and then substitute for 3. Or if you have a flow diagram, which we have there for f of x in peach to represent that function, the inverse function would just be going in the opposite direction, from right to left. So instead of starting at what we call our output, that will be our input. And then what do we do next? We don't divide by 3, we're doing the opposite of everything, going the other direction. So if our input is x on the right hand side, then we multiply by 3. So that will give us 3x. And what do we do after 3x? Instead of minusing 1, we add 1. So we get 3x plus 1. And when we got 3x plus 1, the next thing is divide by 2. So we can write that f inverse x is 3x plus 1. When we get that answer, we divide by 2. So now we can simply substitute for 3. And if we substitute for 3 in there, f inverse 3 would be 3 times 3, which is 9 plus 1. That will give us 10 all over 2. And of course, 2 into 10 is 5. So f inverse of 3, the inverse function of 3 is 5. And if you want to check it back, we can take it and substitute the peach function there, the f of x function, as 5 on the left-hand side. And if we move to the right, we should end up with the answer 3 because we're going in the original direction. So if the input is 5, multiply by 2, 5 2s are 10, minus 1, 10 take away 1 is 9, 9 divided by 3 is 3. So when the input is 5, the output is 3. And if we go in the other way, in the inverse function direction, from right to left, if the input is 3, then the output is 5. So it works. Let's now go on. We're going to move on to 8a, part 2. Derive an expression in its simplest form for f g of x. And of course, we know g of x, that is, g of x is 5 minus x squared. So if we look at what they're asking us to do, we know g of x, so we could replace g of x in the function f g of x. So we're just doing a simple substitution, so it'll be f of 5 minus x squared is what we want. And we know the function for f of x, that is 2x minus 1 over 3. Therefore, instead of having our input as x, our input is 5 minus x squared. So we can substitute 5 minus x squared in there. So it'll be 2 by 5 minus x squared minus 1 all over 3. And now we can just simply expand the brackets and solve. 2 5s are 10 minus 2x squared minus 1 all over 3. 10 minus 1 is 9, so 9 minus 2x squared over 3. Let's go on now to part 3. Sketch the graph of the function g of x in the space provided below. On your sketch, indicate the maximum minimum point and the roots of the functions. So given that situation there, where we have our graph and we'd like to sketch it, of course, if we have g of x, what do we start with? We know that the function deals with x squared, the quadratic. And there are a couple of different ways to do this. One, you can substitute values. When x is 0, y is 0. When x is 1, y is 1. When x is minus 1, y is minus 1. When x is 2, then y will be 4, and so forth. So we can come up with this general sketch here. Most students are taught this, what x squared is. And what do we actually want? We want minus x squared. So how do we get minus x squared? We can actually take this and do a reflection along the horizontal axis, or the x-axis. And now that we have that the blue one represents plus x squared, the red graph, the red sketch represents minus x squared. And if we want to add 5 to that, then all the values of the red sketch will go upwards by 5. So then we can slide it up, and that is our graph, the red graph, not the blue one. The red graph, 5 minus x squared. And on this sketch, we want to indicate where the maximum point is and the roots. So the roots for that red sketch will be where they're cutting the x-axis. So the roots will be at that point here, which is 2.2, and at minus 2.2 when the values are 0 for y. So those indicate our roots, and we want to indicate where our maximum minimum is. Because this is an inverted graph, and you can tell that by the fact that the coefficient of x squared is negative, minus 1 in this case, then it will be a maximum. And you could see that, this red graph. Therefore, we have a maximum value at the point where x is 0 and y is 5. Let's now go on now. We'll be looking at 8, part B. The graph below shows a quadratic function. Part 1. On the grid above, draw the tangent to the curve at x is equal to 1. So if we look at our graph and we would like to find where it is at x is equal to 1, we could go on our x-axis and find 1, and then we could bring it up and we'll indicate the point here with a little small x to indicate that is the point that we're looking for, 1, 3. At this point, we'd like to draw the tangent to the curve. So the tangent to the curve, just a reminder, is a straight line which touches the curve only at that point. So let's bring it up in green. So that's our tangent. Part 2, use this tangent to estimate the gradient of the curve at x equal to 1. So to find the gradient of that straight line, it's the same anywhere along that green straight line along the tangent. We need a second point, and we can see that our tangent passes through minus 2 on the y-axis. So let's consider that using the gradient, because that's what we want to find, change in y over change in x. Let's bring up that point. And how do we get the gradient? We can make it into a right angle triangle. So we can draw a line across, and that is a distance of 1 on the x. And if we're going upwards, it will be 1, 2, 3, 4, 5, from minus 2 to 3. So we know the change in y, that's 5, and the change in x is 1. So 1 into 5 is 5, so we found the gradient. So we use the tangent to estimate that gradient. Let's go on to part 3. Write down the equation of the tangent in the form y is equal to mx plus c. So if we're writing the equation of the straight line, which follows that general formula, y and x must be in the formula, and we need to find m and c. M is the gradient, which we've just found in part 2 to be 5, and c is the point where that tangent, our green line, is cutting the y-axis. And we have it indicated there as a left point at minus 2. As such, y is equal to 5x minus 2. And that's the equation of the tangent. Now going on to number 9a. V, x, y, and z lie on the circumference of the circle shown below. If we look at the circle, we can see all 4 points there. And the center is O. We have that as well, a fifth point, with diameter Vy. So we can easily see this is a circle geometry question. UW is a tangent to the circle at V. And let's recall this list of regular rules that are used in circle geometry. And remember, for each one of these topics here, we have done playlists with at least 2 to 3 videos of past paper questions from May 2009 until 2021, covering all of the questions by topics. So you can go into the playlist and look for circle geometry, and you will find 12 years of past paper questions on circle geometry, and you'll see where these rules are highlighted and explained. So we're continuing with this whole past paper in number 9A. Now that we have that information, remember the angle VXZ is equal to 62 degrees, and that's indicated on the top right side at X, and angle XVY, so it's at the middle letter V, right, is 18 degrees. Part 1. State a theorem that justifies the values of each of the following angles. So for part A, we would like to justify that the angle B is equal to 62 degrees. So one of the things with circle geometry is that there are many different lines for the complete diagram, but what we would like for that particular angle, we don't need all that information. So let us pull out what we need. Recall that the angle B is 62 degrees. So if B is there, then we must have the lines ZY and YV involved. And how is it 62 degrees? Let's pull it out and you'll see. Does it look like any of the rules on the right hand side? Well, it looks like this one. And what is that rule? The rule states that if we're using a chord, in this case ZV, any angles formed from that chord in the same segment, so ZV forms an angle at X, which is 62 degrees, will be equal to ZV forming the angle at Y. It's like sliding it across. And we have a complete video on the full explanation of each of these rules, showing them sliding from one point to the other, so you can see why they're equal. You can check that out as well. It's also in the playlist for circle geometry. Now that we know the angles forming the same segment of a circle are equal, that's the reason why B is equal to 62 degrees. Let's go on to part B. Angle C is equal to 124 degrees. So if we look at angle C, that means angle C is formed from OZ and OV, so it must involve that. And how could they get 124 degrees? Well, let's pull it out so you can see it easier. Right, does that look like any of the rules on the right-hand side? It looks like the first rule. And what does that say? It says that the central angle subtended by 2 points on a circle, which is C, is always 2 times the inscribed angle. Always 2 times 62, which is 124 degrees in this case. And for the third one, the angle OVW is equal to 90 degrees. So it means that when we're extracting it, so we can just look at, or we're erasing the line, so we can look at only the parts dealing with this angle, we need OV, which is a radius, and we need VW, which is a tangent. So let's pull it out. So what do we know? It looks like that fourth rule, where we have a tangent and we have a radius, and there's a right angle there. So the rule simply states a right angle is formed between the radius of a circle and its tangent. So that's the reason OVW is equal to 90 degrees. Let's move on now. Continue with number 9A. Part 2, find the values of the angles A, D, and E. Show all working where appropriate. So first one we want to find is angle A. If we look at angle A, it's actually outside the triangle. So it's considered to be an external or exterior angle of the triangle. So let's consider the big triangle here and pull it out. You can see A is outside, and the theorem says the exterior angle of a triangle, meaning the angle outside the triangle but along the tangent, is equal to the opposite interior angle. So if we have 62 there, which is the opposite interior angle, it is actually the same as A. So therefore A is equal to 62 degrees. Let's go on to D. In order to get D, let's look at that there, then we need OZ and ZV. OZ is the radius. Is there another radius as well? OV is a radius, so we can say they're equal. Let's put up those two lines there. So now, let's pull that out so we can see we have an isosceles triangle because two of the sides are radii, so they're equal. So how do we find for that? Well, if we add up all the angles inside a triangle, we'll get 180 degrees. And since the isosceles triangles will have two angles which are the same, then we'll have D plus C is equal to 180. And we worked out C previously, 2 times 62, which is 124. So 2D plus 124 is equal to 180. If I minus 124 from both sides, I'll get 2D is equal to 180 minus 124. So 2D works out to be 56. As such, the angle D is 56 divided by 2, which is 28 degrees. And we've gotten that part. Now for the last angle here, E. If we look at angle E and angle D makes up a corner of the large triangle XVZ. So we can pull that out. And we know if we add up all the angles inside the triangle, we'll get 180 degrees. So at the corner X, that's 62. At the corner V, it's D plus 18. We know D. And at the angle Z, D with plus E. So if we put all those together, we can say E plus D, which is one corner at Z, plus D plus 18, which is at V, plus 62 is equal to 180 degrees. And we worked out D previously. So we can substitute there E plus 28 plus 28 plus 18 plus 62 is equal to 180 degrees. And we're using the rule that all the angles, the three angles in a triangle, adds up to 180 degrees. And now we could work that out. E plus 136 is equal to 180 degrees. And if I minus 136 from both sides, I'll get E is equal to 180 minus 136. So the angle E is equal to 44 degrees. Let's move on to number 9b. The diagram below shows a quadrilateral PQRS. And this is formed by joining two triangles, PQS and QRS. Calculate the length of QR. So you could bring it up with a little question mark just to indicate what we want. And if we look at that triangle, we have two sides, and we're interested in a third side, and we have an angle. So we can use the cosine rule, which is given in the formula sheet. A squared is equal to B squared plus C squared minus 2BC cos A. Of course, A will be what we have indicated in red as QR. So QR squared is equal to SQ squared plus SR squared minus 2 times SQ SR cos S. So we've highlighted the triangle that we're interested in purple. And now we can simply substitute 16 squared plus 18 squared minus 2 times 16 times 18 cos 25. Remember, your angle of 25 is in degrees, so your calculator must be placed in degrees. So QR squared equal to 58. As such, QR is equal to square root of 58. So QR works out to be 7.6 meters because that's the unit that we're using for length. Now let's go on to the next part. The bearing of P from S is 205 degrees. So if we're saying the bearing of P from S, it means that we're standing at S, facing north, and we're turning to the right in a clockwise direction until we face P. And that angle that we cover there is 205 degrees. Determine the bearing of R from S. So let's extract R and S. And let's see. R from S means we're standing at S, facing north, and then we're turning until we're facing R. That is the bearing of R from S. Now, we just said that the entire angle standing at S and facing P is 205 degrees. So that is made up of three parts. It's made up of the green part, which is the bearing of R from S. We have that in green, or NSR, it's the same thing. And if we add that to 25 and we add that to 72, that will give us our entire bearing, which we have in purple, which is 205 degrees. And knowing that, there's only one unknown, so we can solve. So the angle that indicates the bearing of R from S, or NSR, plus 97 is equal to 205. So we minus 97 from both sides. NSR is 205 minus 97. So the angle, which indicates the bearing of R from S, is 108 degrees north. So that is what we have in green. That if we face north and we turn 108 degrees, we will now be facing R. Part B, we want to determine the bearing of S from P. So we must have S and P involved. So let's extract that. And S from P means that we're standing at P and looking up at S. So we know the information on top already. So let's repeat that we have the north line, and we know that whole angle there was 205 degrees. That was given above. And we can find this green piece on the left-hand side, because the total angle around any point is a circle, which is 360 degrees. So if we add the purple and the green, it will give us 360. So PSN plus 205 is equal to 360. PSN plus 205 is equal to 360. And we can minus 205 from both sides. So PSN is equal to 360 minus 205. So PSN is equal to 155 degrees. And now, if we know that angle green there up above, we're interested in which one? The bearing of S from P. So if we start from P and we look north, and then we turn until we face S, that is the bearing that we would like to find. Or something to recall that we have in blue, that the angles at blue, at P, and the green angle, the two of them are considered to be co-interior angles, because they're connected to the parallel north lines. And if the angles are interior angles, then they will add up to 180 degrees. So the angle which is green plus the angle which is in blue is 180. SPN plus 155 is equal to 180. So you can minus 155 from both sides. So the angle SPN, which indicates the bearing of S from P, is 25 degrees. Let's now move on. Number 10, the last question on the paper. The determinant of the matrix 6 2v minus 5 minus v is 24. Calculate the value of v. Now let's recall, to find the determinant of any matrix, especially a 2 by 2 matrix, then if the matrix looks like A, B, C, D, and we have the diagonals, the major diagonal in red at E and D, and minor diagonal BC in green, then to find the determinant, then we just have to multiply what is in red, AD, minus what is in green, BC. Major diagonal minus the minus diagonal. So let's do the same thing here. This matrix is 6, 2v minus 5 minus v. And if we want to find the determinant of that, it will be the red 6 times minus v minus what's in green, minus 5 times 2v. And from the information given above in part A, we know the determinant is 24, so we can substitute. 24 is equal to minus 6v minus 5 times 2 is 10, so plus 10v. And we can solve. Minus 6v plus 10v tells us that 24 is equal to 4v. So v is equal to 24 over 4, which is 6. So we've calculated the value of v. Let's now go on to part B. The matrices L and M are defined as follows. L is 9532 and M is 2 minus 4. So L is a 2 by 2 matrix and M is a 2 by 1 matrix, 2 rows by 1 column. Evaluate each of the following. So B, part 1, evaluate or find the matrix product LM. So we have a 2 by 2 matrix times a 2 by 1 matrix will give us a 2 by 1 matrix as our answer. So L is 9532 and M is 2 minus 4. And how do we multiply matrices? Just to remind you, it will be what the terms in red multiplied by the terms in black. So it will be 9 times 2 plus 5 times minus 4. And that will give us our first term. And then to get our second term, it will be terms in green times terms in black. 3 times 2 plus 2 times minus 4. So we can have that there. So 9 2s are 18 minus 20. 3 2s are 6 minus 8. So the matrix product LM is minus 2 minus 2. Let's go on to part 2. We want to evaluate L inverse, the inverse of L. So how do we go about doing that? Let's look at the steps for inverse on the right hand side. The first step will be to find the determinant. So we know L, 9532. And to find the determinant, we multiply the major matrix, major diagonal, which is in red, minus the minor diagonal. So 9 times 2 minus 5 times 3. 9 2 is 18 minus 15. So the determinant of L is 3. And what's the next step? We need to find the adjoint of the matrix. And if we have any matrix A, B, C, D, the adjoint just means that we're switching the major diagonal terms and we're making the minor diagonal terms negative. So instead of A, B, C, D, then it becomes D, A, they switch, and negative B, negative C. They become negative. So to find the adjoint of L, that matrix, the adjoint will be switching the major terms. So it will be 2 and 9 are switched, and minus 5 minus 3. And the final part, now that we got the determinant and the adjoint, if we want to find the inverse of the matrix, then all we need to do is 1 over the determinant times the adjoint. So the matrix L inverse is 1 over the determinant times the adjoint, which is 1 over 3 times 2 minus 5 minus 3, 9. And that's the inverse. Let's now move on to the next part. That was the matrix part of the last question. Number 10, part C. PQ is equal to 5 minus 4. If P is the point minus 2, 3, determine the coordinates of Q. So, students have found that it's easier to recognize what's happening here by putting up some sort of representation. So let's make a sketch using a graph. So we just do this freehand, and we could know that the center is O, the origin, and P lies in the second quadrant. We can tell that because the x value of P is minus 2 and the y value is 3. As such, if we go from O to that point, P, then this gives us the position of P. Now we know from there that PQ, that vector, is 5 minus 4, which means that from P, where we're starting, to go to Q, we have to move 5 in the x direction, meaning we're moving 5 to the right. And then we're moving minus 4 in the y direction, which means we're moving 4 down. So we're just averaging this here. This is a freehand sketch that students are advised to make. So what that means is this shows us where the point Q is. So PQ means I'm starting at P, I'm moving 5 across and 4 down. Or I can draw a straight line there, like the hypotenuse, to represent that vector PQ. So we know the vector O to P, and we know the vector PQ. So the vector OQ, we can have that represented in red. And this is what our question is asking us. OQ, how do we find that? By going from O to P and then from P to Q. Do we know OP? Yes, it's given 2 as the to the left and 3 up. So that's minus 2, 3. And then 5 minus 4. So when we add them, minus 2 plus 5 is 3. And 3 plus minus 4 is minus 1. So that's OQ. And you can tell we're correct because Q looks like it's 3 to the right and 1 down, like in the fourth quadrant. In the pentagon, OABCD, that 5-sided figure, OA is parallel to DC. OA is a sloping line to the right going up, and DC is also in the same direction. And AB is parallel to OD. AB is a flat line going to the right, and OD is a flat line going to the right as well. So it tells us about our directions. That is why you can see single arrows to show those that are parallel and double arrows to show the other two that are parallel. OD is equal to 2AB. So the length of OD is 2 times as long as the length of AB, and OA is 2 times DC. Similarly, OA is twice as long as DC. OA is equal to A, we're using that to represent the vector, and B to represent AB. Find in terms of A and B in its simplest form, AD, and we could represent that with a green arrow there. So how do we go from A to D? How do we start at A and move to D? We can go from A to O and then from O to D. So let's write that. AD is equal to AO plus OD. And we don't really have AO, but we have OA. And what's the difference? The difference is the direction will be opposite. So how do we say that? Well, we say minus OA plus, and OD is 2AB, which is given in the second line above. So now we can substitute. We know OA, that is A, and AB is B. So AD is minus A plus 2B. So now we can move on to part 2. Find in terms of A and B in its simplest form, BC. So we have that represented here with a red arrow sloping down to the right. And how do you go from B to C? And the different paths we can go through. So let's consider moving from B, going across to A, then A down to D, and then D back up to C. So 3 arrows. So we can write that BC is equal to BA plus AD plus DC. And BA is really minus AB. AD we have in part 1, and DC is half of OA. So we can then substitute. So minus B plus AD is minus A plus 2B plus a half of A. You can simplify. So if we simplify, minus A plus a half A is minus a half A, and minus B plus 2B is plus B. So BC, going from B to C in the red arrow, it would be similar to if we were moving minus a half of A plus B. Let's now go on to the last part of the paper. Part 3. State the conclusion about the vectors AD and BC that can be drawn from your responses in part 1 and part 2. So in part 2, BC is minus a half A plus B. And if we factorize out the half, we'll be left with a half times minus A plus 2B. You can multiply it and see for yourselves. A half times minus A is minus a half times 2B is plus B. And what is minus A plus 2B? That is in part 1. That is AD. So BC is equal to a half AD. From that, what does it tell us? It tells us 2 things. One, that BC, that vector BC, which we have in red, is parallel to the vector which we have in green, AD. And also, since it's half of it, it means that the length of BC is half the length of AD. And remember, length is represented by putting a modular sign around the vector. So, we have now come to the end of CSEC past paper questions in paper 2. Previously, we did May 2023, the entire paper, and this paper was May 2024, the entire paper 2. Our channel has solutions from 2009 straight up to May 2022, those 14 years, but they are not done as entire papers, they are done by topics. So you can go, and each topic is considered a playlist, and that is seen in the links in the description down below, where all the playlists are listed out, one for each topic in CSEC Math, all 17 topics. And from there, in each playlist, you can go and find all the solutions for each topic, along with any notes that goes along with it. Okay, thank you. Have a good day. Bye.